Everybody. In today's brief video lectures, we are going to be covering crosstabs and correlations. So this first video is going to start with the crosstabs. And anytime you have two variables that are categorical, such as race or any type of dichotomous variables that only have two response categories, like yes, no, what you want to do is basically create a crosstab and then run a chi-square test to see if there is a relationship between the two variables. So in our example, we have smoking and heart disease. And in our little code book here, we can see that for both smoking and heart disease, a 1 indicates no and a 2 indicates yes. And here is our sample data. So the first step in running the cross tabulations is basically what you want to do is create an exhaustive list of all of the different possible response categories. So for instance, we want to start possibly with smoking equals yes and heart disease equals yes. So all persons that indicate both a 2 and a 2, like case 12 here for instance, they have a 2 for smoking and a 2 for heart disease. Then we could do smoking equals yes, heart disease equals no. And then we have smoking equals no, heart disease equals yes, and then both smoking equals no and heart disease equals no. Okay, and then what we want to do is we want to go through and find basically our observed values. And what these are just frequencies of all the people that have yes and yes for both, that have yes and no for smoking and heart disease, and so on through the list. And basically all these are frequencies or counts. That's essentially what a cross tabulation is it's a count of all of the different response categories in our data. Now there are a couple different ways that you can go about basically checking these counts. And the most time-consuming one would be to actually go through and count all the people that have the different response categories. Now in our example we have 200 cases. Some data sets have upwards of 10,000 cases. So this is very time-consuming, and this isn't a very good way to go about counting all the people that have a 1 and a 2. Now there are some kinds of frequencies computations you could run that are a little bit more complex to see like how many people indicated yes for smoking and yes for heart disease. But I think the most straightforward way for us to do this is to do a custom sort. Now you see in the home screen there's this sort and filter option all the way to the right. What we want to do is the custom sort, and we want to sort by both smoking, and then you hit the plus sign for a second sort option, heart disease, and then you click OK. And now we'll see that our data is sorted by smoking and then heart disease. So now what we can do is actually go through and essentially do our counts. So we can see that the number of people that indicated a 1 for both is 64. So we'd have 67 minus 3. So for 1, 1 here, we want to indicate a 64. And then for all the people that said they do not smoke but have heart disease, we go through and count all the 1s for smoking and 2s for heart disease. So we go down here, we see that this stops here at 103. So then 103 minus 67. Here we have 36 counts. And then we go through and do this for all the people that indicated they smoke but did not have heart disease. So all the 2 ones. So 2 ones begins here on 104 and ends on 131. So here we have 27 cases. And then lastly, we want to indicate the people that had a 2 for both. We go down and we can see that they start right here at 131 and go all the way down to 203. So then here we have 73 cases of people that both smoke and have heart disease. These are our observed values. What I'm going to do, just so these all look the same, is format these cells to a number, but only to no decimal places because they're all round integers. Okay, so we have our observed cases. This essentially is our cross tabulation. And for this first step, it's okay just to list them all, not in a 2x2 table, which we'll go over in a minute, but all in a single column. The next thing we do, and this is very important, this is the step that essentially allows us to analyze whether there is a relationship between our 2 variables, is we have to create the expected value for each one of our possible response categories. And essentially what these expected values are is that they are assuming that there is absolutely no relationship between our 2 variables, so between smoking and heart disease. So if there were absolutely no relationship between these 2 variables, then essentially our expected values for each one of our 4 response categories should be exactly the same. So because we have 200 cases and we have 4 possible responses, essentially the expected value is the total number of cases divided by the number of possible responses. So if we wanted to use Excel as a calculator, what we would do is just 200 divided by 4, which is 50. So if there were absolutely no relationship between smoking and heart disease, then we would anticipate that the expected values for each of the 4 possible response categories should all be identical. Now hopefully people get that, but definitely we'll be going over this in our WebEx session this week. But the idea is that this is, in terms of like hypothesis testing, you could think of this as like a null hypothesis, that there is no relationship. And our observed values are what the actual values are for each one of these different response categories. Now, to run a chi-square test and produce a probability value to see if there is in fact a relationship between smoking and heart disease, what we do is we begin our equation with an equal sign, but then we're going to type in chi-square, nothing's popping up, there we go. We type in our chi-square test, and then we put in the actual range, which is our observed values, our counts that we did right here. So we can just click and highlight these. Then we're going to put a comma, and then we're going to put in our expected range, which is our values here. We're going to close the parenthesis, hit enter, and there we have our probability value. Now E indicates essentially that we have to move the decimal place over to the left 6 spots to get this number. That's a little confusing. So one thing we can do is format this cell into a number, but take our decimal places up, and it gives us a sample here. We'll stop right there at 22. And you get that symbol when the number is too large for the width of the cell. And there we go. That is our p-value. Now, if we can recall from memory of the different stat tests that we were exposed to in research methods, essentially in the social sciences, a p-value less than 0.05 is significant, and anything more than that gets increasingly significant. So here our p-value would actually be p is less than 0.00001. And basically, the way to interpret that p-value is that there is a 1 in, let me think, 4 zeros, I believe would be 10,000th chance that the relationship between smoking and heart disease is due to chance. So that's 1 in 10,000th chance that the relationship between smoking and heart disease is due to chance. That's the way to interpret almost all probability values. And essentially what that is saying is that we can be very, 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 very confident that there is in fact a relationship between smoking and heart disease. That's how we interpret that probability value. And these are the steps that are necessary to essentially compute a chi-square. Okay, and for a bonus this week, I wanted to include how it is that we would actually calculate that chi-square test statistic. So the formula for this is found in the accompanying Word document. And what I did here was I basically reformatted our data that we had from the observed values into this 2x2 contingency table right here. And I indicated each cell with a letter, and I wanted to do this so you could see the formula for a 2x2 contingency table crosstab, because in our sample, or in our example, we do have specific counts. But if you go out and do this on your own with your own data at some point later on in your careers, this formula here with the letters is much more informative than the actual numbers in our example here. Because obviously your numbers, your statistics are going to be different. So in Excel, what we want to do is create this 2x2 contingency table for reference. And then once we created that, we'd want to enter in this formula here through typing. And for this, really quick, all I'm going to do is copy and paste this formula in. So first what we do is we create that 2x2 contingency table for smoking, yes and no, and then total. And then for our columns, we'd have heart disease, yes, no, and total. And then here we're just putting in that the same counts that we have in our observed column there, 36 and 64. And then for our total, we're basically just summing the columns here. And then doing the same for our rows. And then lastly, we want to sum all of the different counts. There, and that's our total count in the data set. And now that we have our 2x2 contingency table, it's a lot easier to calculate that formula that I provided. Now that formula is very complex. I know it is. Fortunately for most, even in Excel, for most statistical packages, they do these formulas and computations for you. That's pretty much like the main purpose of having things like the analysis tool pack, or your statistical program for the social sciences, or SPSS, or your R's, and all of those things, is that they do these types of formulas for you. Okay, so I'm aware that this formula is it's very long. Okay, and maybe I should do it by hand, because I would like all of you, for the bonus, to try it by hand, and not just copy and paste. So let me see here. This is going to take a second, and hopefully I don't mistype anything. But the first thing we're doing is we're timesing basically the diagonal rows by each other, and then subtracting one diagonal from the other, and taking the square root of that. So we're timesing 73 by 64. That essentially is both of our yeses, yes for smoking, yes for heart disease, and then both of our no's, no's for smoking, no's for heart disease. And these basically are also like the main two values we're interested in, to see if there is a relationship between the two variables. So we're not quite as interested in the people who had heart disease but did not smoke, or that did not smoke but had heart disease. We're really looking at, if you smoke, do you have heart disease? If you don't smoke, do you have heart disease? So that's where the subtraction of the two diagonal counts is important in this computation. So we're basically multiplying the two diagonal rows by each other, and then subtracting the one diagonal by the other, and then taking the square root of that. Again, this is just part of the formula that the person who created this statistic generated. And then we're multiplying this by the total number of people in our data set. So we know that this is 200. And then what we're doing is we are dividing by basically everybody that indicated yes for heart disease, everyone that indicated no for heart disease, and then everyone that indicated yes for smoking, and then no for smoking. And that is, I believe it would be called our numerator, what's on the lower half of the division. I could be wrong about that. It's been a while since I've taken like a basic math course. And then we're multiplying all of these by each other. So we have 27 plus 64 times 73 plus 27 times 36 plus 64. Closing our parentheses. So I'll stick around, let's type apostrophe first. What is going on here? There's a problem with this formula. Oh, it's right there. My parenthesis right there is in the wrong direction. Okay, so inevitably sometimes you make some minor typos. It'll give you an error. Hopefully you can find out what the issue is. Reporting our results, what we'd want to do is say that we examine the relationship between two categorical variables, smoking and heart disease. We'd want to probably insert this 2x2 contingency table right here as a table in our document so that we don't have to type and write out all the number of yes yeses and no nos. But we'd ultimately want to say that we found support for there being a relationship between smoking and heart disease, comma, and we'd want the write-up to look similar to this. Chi-square with 1 degree of freedom with a total count of 200 individuals. We have our test statistic that we found through our advanced chi-square calculation right here, and you can round to the 100th place. And then we also want to put our p-value. So probability less than 0.00001. Okay, and that is it for crosstabs and chi-squares.